Hello everyone, this is a little video about a device I've made. Can we just get that down a bit? There we go, Tim's Pi divider. This is what it looks like. Let's have a look at it. Let's get some focus. There we go. And so basically we've got a big disc. Well, it's a table. It's a rotating table. It will rotate, around this pivot here. In the end of it, I can never get it. Well, you can see that there's a magnet stuck in the end of there. And what that magnet does is on this part of the thing, it's got three legs. It can be folded away like this sort of thing, folded up, and then these legs can come out. Let's just move that out of the way as well. They come out, and if you tighten them screws up, it'll stay like that. But it's a bit of a handful, just like that, if you're not using it. And what we have, let me just see if I can, well, I'll just move these out of the way again. Can we see inside there? I've got a little sensor just down inside. Let's see if I can get some light on it. Nope. Let's try that. There anyway. So yeah, in there, I'll show you on the drawings. So I'll just open it out and get the legs out. And so basically we have that piece. This is a guide for guiding your knife or cutter for the pie. Basically, and I've got display here. So basically this piece just slots into this hole here. Oh, and each leg has got a wheel on it. So these wheels rotate when the table's on top. So I'll just put that on there, and it just sits on there, and we can just spin it around quite freely. What else goes on there? Oh, right, yeah, so once you've got that set up, we've got our guide here. But what it is, it's a pie divider, so let's bring in a pie. Does this look like a nice pie? It's actually just a I've just printed it out for this demonstration. Oh yeah, and you see all these little holes I put in here. Basically the reason I put all them holes in there is so when you put a pie on top of the table, it helps centralize it, so the pie rotates around its center, and then you've got this little arm that comes across and you can put over the pie, and this is the guide for cutting your pie. Let me just tighten that up a bit. Because I just want it to hover over the pie so it's not actually touching it, because it'll drag against this paper and drag it across. Actually, what I'm going to do is I'm going to stick that down a bit. Just let's stick it down so it don't move. I mean, obviously a pie will be a bit heavier than this, and so it won't move on the table. So let's just stick them two bits, if they'll stick. There we go. And it's stuck there now, so when I turn the pie, the whole thing turns. So it's not going to slip. And this guide goes over it, and I didn't bring a knife. Let's use a scalpel. But anyway, basically, your knife for cutting the pie follows that guide down there. And so let's just plug it in. It's powered by USB power, so that plugs into the it's running off a a Raspberry Pi Pico, and it's got a display on top. See, can we they're focusing on that. So let's just move this right out of the way for a minute, so we can see that. And we can see we've got two buttons. These two buttons, so depending how many portions you want to cut the pie into, how many divisions, you can set the actual number you want. I mean, it's easy dividing it into 2 and 4 and then 8, but when you come to an odd number like 3, you know, someone's always going to want the biggest piece, aren't they? So we'll stick with 3. And so once you've set what you want with 3, you position your guide over the pie. It's got a little handle here as well, so you can just move it. And it'll accommodate lots of pies. Let's see if we can get that into view. So yeah, I've made it on this arm, so it will. You can, depending how thick your pie is, and how big your pie is, you can alter that guide to suit. So yep, there we go. So yeah, you get that in position, so the pie just rotates underneath it like that. The pie can rotate round, and once you've set your number of pieces you want it to cut, you've got some directional arrows here. This tells you which way to turn the table, so that it's telling me to rotate it in this direction. And then you'll see when it goes past the position, goes past the position that you want to cut, it will say go the other way. So you keep, you know, so if I go too far, it'll say go back, and if you go too far again, it'll say go back, and then you get there to where it says cut, and you can see here that it's cut 1 of 3, and basically you cut your pie down this line. And then once you've cut that pie, that piece, you move. It's telling you to move that way, but you've got to go past that point. And when it says no, that means you're in between cuts. So you keep going, and then you'll get the correct arrows again. So you keep following the arrows, and then you'll come to cut, and it'll guide you until you're in the position that you want to cut the pie, and then you slice the pie again. And then you'll want to move round to the next one. Keep going. And oh, I went past it. So yeah, there we go. Oh. There's only like 1 degree of movement between the two pies. So there we go. So we cut, and then we'll cut our third piece. So you can see that it's cut 3 of 3 there. Now, obviously I can't cut it, I haven't got a pie to cut, so let's just take that pie off, and what I'll do is we'll just stick a piece of paper on. Oh, actually I'll just turn it upside down. There we go. So imagine that's our pie. Let's just get it somewhere in the middle. There we go. Let's just stick it so it don't move. There we go. Oh, no. It's gone down that hole. There's that bit of paper. Get me sticky stuff. Really stick it. Don't want it to move. And what to do with my pencil? Right, yes. So basically, let's go back to the start again. So then we can see we're on cut 1 of 3. So there we go. It says cut. So with your knife, what you would do is you use this guide and you would cut down the guide like this. Cut the pie. Then we'd move to the next part. Oh, that hasn't come up very dark, has it? Hang on, let me get a black pen. Right, so we're on cut there. So let's see if we get that black pen there, and we cut it. And then we move. Go past the middle point, then keep going where the arrows tell you to go to cut, So there we're on cut again, so just hold your pi there, then you just do your cut along the guide and then move along to the next one. Keep following the arrows until you say cut. Whoops, there we go. So we go cut again and then you cut your pi again. And then if I move that out of the way, you can see that our pi has been cut into 3 even pieces. And the same will happen. So, well, I'll tell you what, let's just... So I've put the lines on pretty dark, but let's say we wanted 6 pieces. So if let's go with 6 pieces. So let's go to our 1 of 6. There, we've got a cut there. Hang on, move it. There we got a cut there. So let's just... I'll just readjust the guide. There we go. So we've got a cut there. And then obviously the next cut's going to be around here somewhere. So there we go. So there's our cut again. So cut that. And then the other cut's going to be in between somewhere. There we go. Cut there. And then let's keep going. Oh, that's where our cut's going to be. Back there on that line again. And then obviously it's going to be around here somewhere. There we go. Oh no, that way. There, cut. So we cut again. That's 5 of a 6. And then we come round to that one there. That's our last one, isn't it? There, so cut there. And so now we've got 6 even pieces. So yeah, that's my pi divider. So you've seen how it works, and you just need a nice and juicy pie instead of a piece of paper, of course. Let's move that. Let's have a look at the actual construction and things. Now, like I said, this display that I've used, let's just bring that up. So, well, let's just run through my instructable. That's the easiest way, and then we can see that we don't miss now. So, yes, the parts. Let's have a look at our parts. We need one of these things, and one of these is what you can get from these guys. It's just a display. You can either plug it onto one of their boards there, or it plugs directly onto the Raspberry Pi Pico, like you can see there. All the information about it is there, basically. Just point to note that it uses this driver, and the driver that I got for the MicroPython. It's a pretty much a basic driver, but I've managed to be able to put, well, I've managed to put some graphics on. Let's just restart it. I'll unplug it and restart it. You can see I've managed to put my logo on it. And then obviously we've got text and our direction arrows. So let's go back. Here we are. Yes, so that's the LCD that I've used. It's also got the 2 buttons on, which we need for setting the number of people, well, the number of pieces you want to cut the pie into. Yes, so let's go back to this, and this is the chip. Well, this is the type that I've used, and it's what I've designed. If we go to some parts, where's our plastic parts? Yeah, our plastic parts. It screws onto this board here. Can we make that bigger? Yeah. So this is the middle bit. Let's go back to our live view. I'll just remove this. Remove the table for now. All this has the spindle part in the middle. And well, spindle part with a magnet. We'll come to that. I'll just zoom in. There. So that's spindle part with a magnet, and that's just screwed on with 3 screws. And this part, I'll just unplug it for now. Don't lose that cable. And this part here, the bit in the middle that holds all the legs together, sort of thing. You know, all the legs are screwed to it, and this little bit of plastic is screwed to it. But this bottom board, I've designed it to take that type of sensor that I've shown on the Instructable. So yeah. So those are the plastic parts, and obviously if you don't have a printer, a 3D printer, you can get them made out, and because I may get something from it. So basically there's these 3 plastic parts that need printing, and I will I've listed the 3 parts here. And if you want to get them printed out, there's a nice place which I use, which is PCBWay. If you go to 3D printing, so I'll just move down to 3D printing here, and what we can do is we can add. Now this sheet is for each individual piece. So what you'll do is you'll select a CAD file. So let's just go to my divider, and let's say let's get that bottom one. This is the base. So you'll upload the 3D piece, and you can see there the 3D view if you look at it. I think it's doing something. There it is. There we go. There you go. You can see the 3D view, and now you can actually see where that sensor screws to. But yes, you can check that, and then the number you want, it'll be just 1. There we go. And well, it may be cheaper to make it out of resin. I don't know, nylon. Oh, that's dearer. PLA. You see, I've made mine out of PLA, but the price there for one is nearly $8, whereas for a resin print, it's only $5. And really, if we look at this, you know, it doesn't need to be that strong or anything. I should think a resin one would do, maybe. You may have to look at how well the screws screw into it. I don't know how brittle the resin is. So yes, so the choice is yours. I mean, it's just a piece to hold one. Well, if you want to add another one, you basically select another one here. So you have to do this 3 times. So there's the pivot. Where are we? Get to the top. Yeah. So there's the pivot. Oh, that's the base. Yeah, I've just clicked the pivot aligner. So you'll need 1 again, sort of thing. And then you can 3D view it. There we go again. So 3D view it, and there it is. And obviously choose which you want, resin or PLA or one of these other 2. It doesn't really matter. I don't think you want aluminium. I don't know. I wonder what price aluminium is. Oh, look at that. Well, you know, if you really wanted one that will never break. Anyways. So yes, so once you've done that, then you add the 3rd one. Which one did I just do there? Oh, that's a center. Is that the pivot there? Where are we again? Oh, back to the top. Yeah, so there's the other one. So you've got your 3 pieces. You put your quantity 1 in there again, and then you choose. Like I say, I've made mine out of PLA, but you know, the choice is yours. PLA is a nice soft thing, and then you obviously just follow the rest of the stuff to where you postage and where you want to send it and stuff. So let's get back to the instructable. Yes, so there's the three pieces. Now also what I need to do is I want to talk about cutting the parts. Now I've got that's my laser cutter. It's a CNC machine. I've made a cover for extracting all the smoke and everything, and it takes a nice laser. And this cuts 3mm hardboard really well. And when it comes to cutting plywood as well, it cuts plywood even faster. Anything without gluing cuts really quick, but as soon as you start adding stuff that has a bit of glue in, then you've got to slow down, because when you're cutting with the laser, you don't burn the glue, you actually melt the glue out, and it drops out the bottom. You've got to slow down and give it time for that to drop out. Anyways, I digress. So I've got a laser cutter, and by chance it's what's called kerf. Right, the kerf is how much the laser cuts out of whatever you're cutting, so you're going to end up with a small gap in between these, and I'm able to put all my pieces together right next to each other, and I don't have to do any tolerance fitting, because the kerf that it cuts out is just enough to let a piece fit inside a hole. I'll explain further. So to explain it, I've tried to explain it here, but if you're getting these made out, you may need what I've done is I've put in two types of file. Now these all single files are exact sizes. That is, the hole is 3mm, but if you're fitting a 3mm peg into a 3mm hole, it will not fit. You have to make the hole slightly bigger for the peg to fit inside the hole, and this has not been allowed for in all these single files. But what I've done is I've done a file. Well, let's just stop that. I've done a file in which I have added the tolerance fit, and there's also the file that I have used for my laser. Now my laser doesn't need any offsets or anything adding to the programming of the cutting, because the kerf the laser cuts out is exactly the right amount to give a tolerance fit. So I think I can best explain this more with a drawing. So let's bring up this drawing. Right, so let's imagine this piece. Let's bring this back up. Right, so I've got this piece here. So we've got a top here. Let's see if we can get some colour and light on it. There we go. So focus. So, and then it's got these two legs that fit through the top either size. Now the hardboard I'm using is 3mm thick. So this hole that the hardboard has to fit through needs to be slightly bigger than 3mm. But like I said, I've drawn all the files exact sizes, so the holes will only be 3mm apart. But obviously when I cut it with my laser, it makes the hole slightly bigger and allows the 3mm to fit through. So let's just go back to the drawings. Yeah, so I've originally drawn them like that, and what happens if I go here and I turn on the tolerance fit, so you can see here these holes have to be actually cut a little bit bigger excuse me, a little bit bigger for the 3mm to fit inside the hole. So if you are getting these pieces cut out, that the pink is the size of hole that needs to be in there, because they use industrial machines that might have a larger curve. The cutout, the amount that the laser cuts out is bigger than the amount of my home desktop laser cuts. So if we look at this hole, for instance, and I turn on my laser, so my laser is going to follow this actual line here. It's not going to follow the hole that you actually need, which is the tolerance fit. So I'll turn my laser on. You can see that the green is what it cuts out. It removes this amount of material as it's following this center line. So it actually ends up the correct size for the tolerance fit. So this is the difference between the files. So if you don't have a desktop laser of your own and you're not cutting them yourselves, you need to take this into account when you are making things yourself and you want things to fit inside each other. You've got to find out what is, let's turn my laser off, how bigger the hole needs to be for your piece to fit inside, and that's the size you need to draw it. So you would draw it with just the that size, which is bigger than 3mm. You can see these dots, these are 1mm apart, and you can see that it's slightly bigger, and it allows the other piece to fit inside the hole. So this is so what I've done is I have done a file with them all in. This is what you would use to get them cut outsourced by a professional, and all the files I've had the holes enlarged so that when they cut them, they will be cut the right size. This is the size that I use. This is the size you need to use when you have them cut out, because their programs for their machines will allow for the curve that is cut out, and it will offset the path of their machine. Let's go back to the other piece. There we go. So we turn on the original. Now, like I say, the ones that you set, I'm sorry if I'm rambling on a bit, but it will be maybe of interest to those that don't know about these sort of things. So I'm just trying to say that there's two types of file, and you need to use the right one depending whether you're cutting them yourself or you're getting them outsourced from an external supplier. So it won't be this size hole that are in the files for the external. So if we turn them off, and what I've done to demonstrate this is say that the supply that you're getting them made from will want this size, because what they will do is in their software they will set a curve, and when they cut with their lasers, what they will do is cut it. Their programs will automatically allow for this curve, so that curve, shall I say, the amount that's cut out is always on the inside edge of the hole, and you end up with the hole the right size. Whereas if I cut it, my laser cuts following this line. My laser follows that line, and then when it cuts, it ends up giving me the tolerance fit. But an industrial laser will want this pink line, because that's the line that they will work to, and their machine will adjust automatically to cut with inside that curve. It's the difference between industrial machines and home desktop lasers, basically. I hope I've explained that quite well. So basically, if you're using your home desktop with a right tiny little diode laser, then you can get away with this file, which basically it just goes over each line once, and then you end up with everything cut out. But if you're getting them cut out by an industrial laser externally, then you will need this file where you can see that I've spaced everything out, and this gives their machines room to go around every part, and then so when they're cutting in between the parts, they're working to this edge and this edge, and everything gets cut out in between the thickness of their laser, hopefully. Well, I wanted to say that, try and explain that. I'm not a very good explainer. I hope you understood. So let's move on. Right, so what we got? Yes, yeah, we got all the parts. There's a little bit of soldering to do. You just need a few. Well, I have boxes of capacitors and connectors and resistors, so you know it all comes apart. Now what I've done is, see these straws here, they're about 3.5 mil thick. I've put a link here, holoplastic lolly sticks they are. Let's have a look at that. Yeah, these things, eBay, it's the ones that are hollow, it's got a hole down. I've noticed that there's two types, there's some solid ones and then there's some with a hollow down. I think it's this type that you want. You just get a pack of so many. Yeah, what that is, it's plastic. It's nice, quite shiny plastic, and what I've used it for is, let's just get a view on there. There we go. I've just used it for the spindle on the wheels, and this hardboard runs really nice and freely over top of around the plastic bit of straw through there, so you can see how how thick it is and what have you. So yeah, that's that. I think the next main bit is obviously, well, the Instructables is going to. I've done little feet, little rubber pads on this, but yeah, you don't need them. You can do if you want. But let's get back to the Raspberry Pi Pico, and you can see that I've actually. Let's just see if I can get that in focus there. Yeah, I wonder if I can get some light on it. There we go. There's just a resistor and a capacitor there. That's so it's not mandatory. It just stabilises the readings a little bit. It just cuts out a bit of interference. So let's get back to the Instructable. Yes, so that's how my laser cuts stuff out. It's really nice. Oh yeah, I do have a program of my own that I've written. If you have your own little CNC laser cutting machine, you may be able to create your G-code files from this. It's quite. I think I've done a demo on my web page. But basically, the main thing is to make it. Most CNC machines for the desktop things are all GRBL based machines. So just make sure you have this ticked, because it gives you different commands for the cutting. Turning the laser on and off. This is my cut speed, and that's the value is 0 to 1000. So it's on full there. It's 1000 for the laser, basically. That's the main important thing. So once you've got it loaded in and previewed, you just generate G-code, and then you save all this. You can edit this in there if you like. Anyways. So I think I've tried to explain all that in there. I've given you what pieces you need of each. Oh yeah, and because like I've made mine out of this hardboard. It's got this white finish on it, and the other side's like a plain hardboard finish. Sometimes you may want, like with the legs, you may want to make an as drawn piece, and then on the other side this wants to be opposite hand, so you get the finished side on the outsides. So that's what I've done in the well, I've put in the instructable. Yeah, so I've put down here 3 as is and 3 opposite hand, basically. So we have all our files, our plastic, and then I've put how to assemble it all. There's 3 screws on them, glue all these pieces together. I hope that shows that okay. And like I said, one of the legs will have this display added. I'll just move that. One of the legs will have this display added, and the mount for this arm, the guide. Looks like that. And then we've got this. Oh yes. So right, the thing with this AS, well, even if you've got a different one and you've managed to make it fit, the AS5600, usually when you get them off eBay or what have you, as a little breakout board like this, they're designed to work with 5 volts because it's the Arduino thing. Well, I suppose it's now the old Arduino thing. The original Arduino thing was 5 volts, but we're getting so many new microcontrollers out now that, well, like the Raspberry Pi Pico, they run on 3 volts. So we need to convert this to run with 3 volts rather than 5. And I've attached the PDF datasheet for the chip. And if we look in the datasheet, you will see that there are 2 pins for the VDD. One is a 5 volt pin and one's a 3 volt pin. Now, the 3 volt pin, you don't just use it on its own, you use the 3 volt pin with the 5 volt pin for 3 volts. So this will need linking. Now I've just, where these capacitors are, I've just linked a wire between these 2 ends of the capacitors. But if you look at the chip, you've got pins 1 and 2, which is the VDD for 5 volts and the VDD for 3.3 volts. You could just bridge these 2 pins together. If you can get in there with a soldering iron, it may be easier for you to put a wire in there. But you know, my eyesight's going. It was easier for me to just solder a wire between these 2 points, which actually are linked to these 2 pins, like this. So you just put a bridge across there. That's all that's required, and then you're in 3 volt mode. There is, however, this capacitor will be left on there. It doesn't matter, it doesn't make any difference. It can be left there, so you don't need to remove that. You can see that there isn't one there. This is more for when you want to start. You can actually program these, but we're not doing that. All we're using is these 3 pins here, which is the power pin, the ground pin, and the PWM pin. Well, actually, it can either be depends how it's programmed, but basically it's a variable voltage. That's how we're using it. It's a 12-bit generated variable voltage. So anyway, that needs doing to that. So you need to modify that before you do it. And all I've done is I've just put my 3 cables on there, and I've put a plug at an end of this cable, and I put a plug on the Pico. I put a plug on the Pico as well, so it can be unplugged and removed, basically. So yeah, so there. What I've done is I've added a bit of smoothing. So where I've actually, that's my little socket that plugs into the sensor. So I've put a female socket on the other end, and that plugs in there. And then we've got the ground, the 3 volts, and then we've got the signal pin here. And what I've done is I've just put a capacitor across them pins and a resistor here, and that just smooths out any sort of high level interference basically. It just gives a smoother reading on the display, that's all. If you don't have them, you can just put that wire there straight onto this GP28. It's the 28 that's being used for receiving the signal. There it is fitted inside. It's better. It's you can see it better there. You see I've got the plug coming from the sensor there and plugged into the pins of the thing, and it all fits nicely inside. And the Raspberry Pi Pico just plugs into the display. The display has sockets for every pin on the thing. And and I've done a fritzing to sort of simplify it. Here's another type of sensor that is out there. If you can only get them, then just glue that to the center plastic bit. If you just glue it down, it will do, as long as there's room for the magnet to hover over the top of the sensor, basically. And I've shown a different display here. I've done the fritzing, so if you don't have one, if you want to make this without that type of display that I've used, then these are the pinouts for the display. It needs to be ISA type, because that's the code I've used basically. There's the wiring diagram. So hopefully that's sorted that bit. And then programming, well, it couldn't be any easier really. No, normally a Raspberry Pi Pico comes with MicroPython already installed. It's like having an operating system on your computer. What you do is you download your code to the microcontroller, and MicroPython reads that code, compiles it, and then runs it. Rather than with the Arduino IDE, you've got to compile it and upload direct to the actual system of the microcontroller. The Pi Pico has a larger processor, a lot more memory, and it's able to run MicroPython on board. So all you have to do is just write your code and upload it to the Raspberry Pi. I've used Thorny. There are many IDEs that you can use to upload the code. All you have to do is all you have to do is to get these files onto your Raspberry Pi Pico. These 2 files need to be into a folder called lib, but once they're all uploaded, it should be hunky-dory, all ready to go. What I've done, because I think that I may end up doing more projects with the Raspberry Pi. I've got some others of these, so when a project I think the Raspberry Pi is good for, well, Raspberry Pi Pico should I say, is good for, then I'll do some more instructables. And I thought what I would do to save a bit of writing, and I hate repeating myself, is I'd do an instructable on how to actually upload the code to the Raspberry Pi. So I've separated this out, and I've already done an instructable here on how to upload code. It's a basic instructable. All that I'm trying to achieve here is actually show you how to actually upload code to the Raspberry Pi Pico, and nothing else. I'm not trying to tell you how to program or do anything. If you've got like files supplied by me, then I just want you to be able to upload them to the Pico so that the project works. And so I've done some examples, and since this was the first example with using the Raspberry Pi, I'm using the same files as I am for my Pi divider. So, you know, obviously these files won't refer to any other I do in the future. But it's the same procedure anyways. So yes, oh well, I'll show you anyways. So yeah, here's the Raspberry Pi, and let's just move this out and just move this over here a bit so you can see. Obviously, once you start it up, like I said, just make sure that you've got this ticked and this ticked. This shows the shell down here, and it shows your files here. Now at the moment you can't see what's on the Raspberry Pi Pico because it's not plugged in. So let's sort that out and plug it in. Where are we? That way. There we go. And obviously when you plug stuff in, the first thing to do is press stop, because it's actually running on this on your microcontroller. It's running on your Pi Pico, and you can't talk or change files while it's actually running. So click stop. Oh, hang about. I've got something wrong here. Let me just change that. Yeah. So let's just check what. I can't remember what. Oh, not that one. Right, which one's it connected to? Ah, right. It looks like it's got so many. Yeah, it looks like it's number 10 there, the serial device number 10. So what you need to do is you need to go to run and configure the interpreter. You need to tell it what you've done. Oh yeah, I remember now. I was using this last time. So if you had been using something, a different microcontroller previously, when you had it open, that's what it'll remember. So you need to change it back to what you're going to use, because obviously if I've got it set to this, then it can't talk to a MicroPython Raspberry Pi Pico. So we'll do it, change it to that, and we're on content. There we go. So we go OK, and there we go. Now we can see the files, because the interpreter's now got the right language to interpret. Yes, so basically all you need to do, right, rather than select go like this, like this, you know, holding control down, select everything and then copy them across. If you've got something in a library, and I suggest you save them on your own computer the same way that you're going to save them on your microcontroller, is put them in the folder if they need to go in a folder. So if we select that one and control to copy a multi-computer, all you have to do to your microcontroller, all you have to do is go down to upload, and it will upload all those files to your well, let's do it. Yeah, overwrite. So we'll go from that, and that's it. That is how easy it is to program this. Once you've got the files, you just copy them across, and then they all show up on your Raspberry Pi Pico. Okay. Now, oh, right, yeah, and I do know that, right, so I do know there's people out there that, oh yeah, notice these tabs are not in brackets, so these are referring to these files here, basically. If I close them, right, and we open up, let's open up the logo on the microcontroller, you can see that it's in brackets. That differentiates between these files and them files. On your microcontroller, they'll be in brackets. Now the logo, let's just start this up again. There we go. Can you see Tim logo there? It starts up when the program starts with a little picture of, with a little sketch of me. Let's go stop again, and then we've got our Raspberry Pi back. This is the logo. This here is the logo that came up, a picture of me. and I've got a little program should you want to use it. Where are we? Here we go. There we go. So I made this little program. I wrote it, and that's my little logo that comes up there. This one happens to be 48 by 64. If you want to make a bigger one, then obviously what we'll have to do is go to the main code, and if you somewhere about, where are we? There we go. Draw image there. Logo. That's the file that is loaded, and it's that size 48 by 64, which is the size here. It tells you there that 48 by 64, and we can view that full height. There we go. And if we want to, these are just shortcut zooms. You can just use your scroll mouse to zoom in and out, or you can go full width and what have you, and then you can edit, put your own thing. You can load your own file and convert it and change it and things. And then if you want all, as we look at the logo, see all these bytes here. To get all them bytes, all you do is just get data, and it converts all those into bytes, and then you just copy all and paste it into this bit here, and then you'll have your own logo should you want to. I know that people do. Yes, so right, so that's that bit about programming. Let's get back to the instructable. Where's my instructable? Have I just closed it? Oh, hang on, no, I moved it across. I didn't put it behind, I moved it across. Yes, so I've done all the sticking together a bit, and then how to use. So hopefully at the beginning of the video, and I hope you're not bored out your mind by now. If you've made it this far, great stuff. So basically these are pretty much what shows up. It tells you which direction you want the pie to go, to turn the pie, and then when it gets onto the cut, this is the action you take. You do a cut along that line, and that's it. That's the end of the video. Well, I hope you enjoyed it. I hope you found something useful, and I hope you like what I've made. I hope you like. Where are we? Yeah. Obviously I'll stick this video on end of this. I hope you like my pie cutter. There we go. So yeah. So here we go. Let's just open it out again and lift that up. Stick that on the middle so it spins nice and freely. Get me fake pie. Yeah, there we go. Oh, it looks alright on the video though, doesn't it? Yeah, you could definitely eat that guy. And then you stick the guide where you want it, and off you go. It's on to. Oh, actually, let me just get rid of thought. Right, let's just get to disconnect from that. Well, actually, you can play from here if you want into thing. But is it running? No, is it? Yeah. Let's just turn that off. Right, and then I'll just reboot it. There we go. And then there we go. So set how many you want. Hang on, let's move that. There, yeah, like I say, it'll only go down as far as 2, because obviously if you want 1, you've already got 1, haven't you? So 2 is you slice it right in half, but then it'll go. Well, I'm guessing it'll go as to how many you want, but how many times can you cut a pie into? That's the question, and you tend to want more than one mouthful, don't you? So yeah, so there we go. And well, I hope you enjoyed that. Thanks for watching if you did, and if you got to the end, yeah, thanks very much. Catch you later on my next one.